All right, let us see this example where it says that use the power series of 1 over 1 plus x and the derivative. We'll find out the power series of that, and we find out the derivative to find the power series of that, because the derivative of that is this function, right? So we'll find out the power series of this function, and then we find out the derivative of that, and then that will be the power series of that function. Okay, guys. So let us do that. So what it says is, so solution is, we know what is the power series of 1 over 1 plus x? That is same as 1 over 1 minus x, right? So that will be given as so summation n equals to 0 to infinity, and then a is 1, and then r is negative x to the n, right? So that is same as summation n equals to 0 to infinity negative 1 to the n times x to the n. You see that? Now let us find out the derivative on both sides. So what is the derivative of 1 over 1 plus x? The derivative, so if you find out the derivative on both sides, what do you get? Then you, on the left hand side, you get d over dx 1 over 1 plus x, right? So, and then on the right side, it is d over dx, and then summation n equals to 0 to infinity negative 1 to the n, and then x to the n. You see that? That's what you get. Okay, guys. So n equals to 0 to infinity. You see that? So if you do the, for example, look at this. When n equals to 0, because if you expand this, how that look like? If you you'll get 1, okay, and then minus, because when n equals to 1, it will be negative 1 to the 1, and then x to the 1, that will be x, minus x, and then plus, if you plug in 2, then you get x squared minus x cubed, and so on, right? Now when you find out the derivative of that, then the derivative of the first term will be 0, right? So it will start from x. You see that? The derivative of that will start from x. Okay, so basically you don't have to do that part, but you need to understand what happens when you find out the derivative. The 0th term will be 0, because the derivative of 1 will be 0, derivative of x will be 1, derivative of x squared will be 2x, like that, right? So if you do that on the left side, you can use the quotient rule, or you can move that to the top and then find the use the power rule. You will get negative 1 over 1 plus x to the square on the left hand side. On the right side, you will get summation n equals to 1 through infinity, okay, and then negative 1 to the n, and then times nx n minus 1. That is the derivative of that term. You see that? If you expand that, what do you get? If you plug in 1, you will get negative 1, right? You see that? Negative 1 to the 1, and then 1 times that will be negative 1. You see that? And if you take n equals to 2, what do you get? Negative 1 to the 2 will be positive, right? And then 2 times x to the 1, that will be 2x minus 3x squared, and then so on. That's what you get, right? But how do I write this in this series format if you start from n equals to 0? That is, you get negative 1 over 1 plus x squared, right, equals to, you get summation n equals to 0 to infinity, because the power series starts from 0 to infinity. So that will look like n equals to 0 to infinity, right? And then how does it look like? Because you see that if you start from, so you can replace n by n minus 1. N by so n minus 1 will be 0, right? So you can write that as n by n plus 1. Replace n by n plus 1. Okay, if you replace n by n plus 1, what do you get? That will become n plus 1, that is 1. So 1 and 1 will cancel out, so you will get n equals to 0, right? So you will get negative 1 to the n plus 1, right? Negative 1 to the n plus 1. You see that? If you plug in n equals to 0, you will get negative 1 to the, that will give you that. Yeah, negative 1 to the n plus 1, and then n replaced by n plus 1 here as well, and then x to the n. That's what you get. Okay, so this is basically, this is a power series with this one is like an, this is like an, and then x to the n. This is a power series around c equals to 0. You see that? That's what it looks like. So the final answer is -1 over 1 plus x square is equals to summation n equals to 0 to infinity, right? And then -1 to the n plus 1, and then n plus 1 times x to the n. That's the power series. Okay, so this is not hard, but this is a little bit technical there. All right, so let us do the same thing to find out. We need to use the integral for that. Find the power series of 1 plus x, and then we need to do the integral to find out the natural log of 1 plus x, because the integral of 1 plus x is that. Let us use the same thing. We know that solution is, we have 1 over 1 plus x is equals to, you have summation n equals to 0 to infinity, -1 to the n, and then x to the n, right? That's what we use from there. Now what we do is we are trying to find out the integral on both sides. Okay. Oh, by the way, okay, that's fine. So I will find out the interval of convergence at the end there, because the interval of convergence here will be how would that look like? So the interval of convergence is, this is basically the basically you can use the power rule, okay, and not the power ratio test. You can find out like limit n tends to infinity, okay, and then absolute a n plus 1 over a n. If you do that, what do you get? You will get the absolute value. You will get n plus 1 over n, that will be just 1, and then x to the n, so it will be just mod x, absolute value of x. When does this, so what is the interval of convergence? So this series converges if mod x is less than 1, that will be -1 to 1. That is the interval of convergence here. Okay, so similar thing we will be using here, but let us find the integral here. So integrate. If you integrate, you will get integral of 1 over 1 plus x dx, right? That's what you get. And then on the on that side, you get summation n equals to 0 to infinity, -1 to the n, x to the n, and then we will do the integral as well there. Okay, we find out the integral here as well. So what do you get here? That will be natural log of 1 plus x. Okay, that's what you get, and that is the left hand side. That will be the, so the, we are trying to find out the power series for natural log of 1 plus x. That's what we got. And when you do this one here, what you get there is, there will be a constant term there, right? So it'll look like summation n equals to 0 to infinity, right? And then you write the integral of that will give you -1 to the n, x to the n plus 1 over n plus 1. You see that? That's what you get for the integral of that term will be x to the n plus 1 over n plus 1, and then there will be plus c. Okay, and then c is just a constant. So now what will be the interval of convergence? Again, you can use to find out the interval of convergence, use the ratio test. You get limit n tends to infinity, a n plus 1 over a n will be what? I can show how that would work. So it will be, so what will it, this absolute value will get rid of that -1 to the n, right? So you can write x to the n plus 2 over n plus 2, that is a n plus 1 times n plus 1 over x to the n plus 1 absolute value. If that, when n tends to infinity, that you take out n, and then that one, that n, and then that one, that term will become 1, and then that will be just absolute value of x. Okay, because you see that how I wrote that, that will be like n plus 1 over n plus 2, take n out, 1 plus 1 over n out, 1 plus 2 over n, right? That n and n cancel, and when n tends to infinity, this will be 0, this will be 0, basically 1. That becomes 1, and then x to the n plus 2 over x to the n plus 1 becomes just x. That's what it becomes, right? So so the interval of convergence is a mod x is less than 1, that is -1 through 1. That's what you get. Okay guys, so this is how By the way, we need to check because we are using the ratio test, okay? So we need to check if it converges at the endpoints as well, on both cases. What happens if x is -1? So it will be -1 to the n, right? So -1 to the n. And what happens if it is +1? So if it is +1, that will become by the way, when it is so when x is -1, that will be 1 plus -1, that will be infinity, so it will not converge, right? When x is +1, that will become 1 to the n, right? And then what happens, that will be 1 minus 2 plus 3 minus 4, like that. So it will diverge at -1 and +1. So this is the interval of convergence here. But what happens on this case, if x is -1, that will become infinity. So -1, it will diverge. At x equals to +1, it will be +1 and then 1/2, 1/3, and so on. So it will basically, this will converge, okay, at that time. So basically the interval of convergence will be like that, because you can use the, I think, alternating series test to see if it converges or diverges at x equals to it will become -1/2, +1/3, and so on. So it will be decreasing, it will be decreasing, all those. So and then the decreasing, and then the derivative will be negative, and so on. So you can use the alternating series just to see that it will decrease, it will be convergent at +1. So the answer is -1 to +1 there, okay? That's what you get. All right, so you can use these kind of techniques with the derivative and antiderivative to find out to see basically the derivative, antiderivative, and the power series, to find out the power series of other complicated functions. Okay, guys, so what I want to do is I want to do one more example for you guys. Okay, guys, let us see one more example. All right, let us see example from the book. It says find the power series representation for fx equals to natural log of 1 plus x squared. You want to find the power series representation for that, okay, at c equals to 0. Also find the interval of convergence. So it is a little bit tricky. The reason why it is a little bit tricky is you need to find out, you need to consider a function whose integral is natural log of 1 plus x squared. Do you guys remember this? Do you guys remember that integral of f prime over f equals to natural log of f, right? It's like that. So if you have u prime over u, that will be natural log of u. So do you consider a function that has denominator 1 plus x squared, right? Because we have natural log of f is 1 plus x squared here. That should be natural log of 1 plus, so 1 plus x squared should be on the bottom. Natural log of f, that should be on the bottom. And then the derivative on the top. So what we need to do is, let me write this here. We know that 2x over 1 plus x squared can be written what? You can write this as 2x times 1 over 1 plus x squared, right? Can't you write like that? And this can be written as 2x is there, and then write that the power series representation for 1 plus x squared. So n equals to 0 to infinity. You can write, you know what I mean? This is like 1 minus minus x squared. You can write like that, right? So it will be a is just 1. Okay, you can write 1 there, and then you can write that as negative x squared to the n. That's what I get. Okay, guys, so that can be written as 2x times summation n equals to 0 to infinity -1 to the n times x to the twice n. Okay, and if you move this inside, what do you get? You get basically summation n equals to 0 to infinity, right? And then you can write -1 to the n, and then 2 times x to the twice n plus 1. This is the power series for 2x over 1 plus x squared. Now if you integrate on both sides, dx, and then integrate on both sides, dx, okay, so what do you get? You see that the derivative of the denominator function is on the top. That will be natural log of 1 plus x squared. I didn't write the absolute value because this is positive quantity, right? Now we need to find out the integral of that on the right hand side. What do you get? If you find the integral, you will basically get summation n equals to 0 to infinity negative 1 to the n to the derivative of x to the 2n plus 1 will be x to the 2n plus 2 over 2n plus 2 and then plus c. Okay guys, that's what you get here. Okay, so here you can factor out 2. So if you factor out 2, how that look like? 2 and then n plus 1, that's what you get, and that 2 will cancel out. So basically what you get here is basically you get summation n equals to 0 to infinity, right? And the negative 1 to the n, and then you get x to the 2n plus 2 divided by n plus 1, and then you get plus c. Okay, so what is the interval of convergence here? If you plug in x equals to 1 on here, you get the log is defined, x equals to negative 1 log is defined. So the interval of convergence is negative 1 to 1, like that. You see that? That is because you see that on this function, on basically how do you find out the interval of convergence? Exactly the same way. You can take the ratio test as we did before, and then you will get the ratio test will be absolute value of x. So you will do like this, right? Limit n tends to infinity a n plus 1 over a n. If you simplify that, you will get absolute value of x. And when you do this series converges for less than 1, okay, diverges for greater than 1, and it is inconclusive for a equals to 1. So at equals to 1, then you will have to put x equals to 1 and negative 1. Then you get that this is finite, meaning that the series converges at negative 1 and positive 1 as well. Okay, so that's why I got the bracket there. Okay, now the thing is, how do I find out the value of c? I forgot, I think in the last example I forgot how to find out the value of c. What you can do is you can pick any value in this interval, okay, and then find the value of c. Let us try that one. Okay, to find c, and use the same technique. I think I forgot to do that in the last example. So use the same technique. After you find out the interval of convergence, pick any point in that interval, any value of x in that interval, and then find the value of c. Okay, to find c, take x equals to 0. If I take x equals to 0, what do you get in the left side? You will get natural log of 1 because x is 0, right? Equals to in the right hand side, what do you get here? You get summation n equals to 0 to infinity. You get negative 1 to the n, 0 over n plus 1. Oh, that will be 0 plus c. So that is 0 equals to c because natural log of 1 is 0. So you plug in that. So basically the series representation will be summation n equals to 0 to infinity, negative 1 to the n, and then x to the 2n plus 2 over n plus 1, and then the interval of convergence is negative 1 to 1 with bracket. Okay, so the idea here is, this is a little bit tricky because the question is asking to find out the series representation for that, but you need to start with that because you know that the integral, if you find the integral of that, then you will get the natural log of 1 plus x squared. Okay, so we are basically using a function and its integral to find out the series representation for that function that you want. Okay guys, that is the end of the video.